Now, we'll be dealing with the types of open channel flow. So, in this lecture, we'll be dealing with types of open channel flow. So, there are various types of open channel flow, but we'll be classifying under 4 different types. First one is types of open channel flow based on shape. Second one is based on construction. Third one is here based on cross section and slope, and last one is here based on boundary characteristics. So basically, as I have written all the 4, in this 4 broad points or in this 4 types, we'll classify the various open channel flow. So we'll be dealing it one by one. First one is your based on shape. So first one is your types of open channel flow based on shape. So based on shape, first one is your rectangle. You'll encounter questions also, rectangular open channel flow, a wide rectangular open channel flow. So the shape is rectangle. Let me nomenclate it also here for you. If this is your width, this is the water, and this is your depth of flow. Fine. So this is what? Rectangular open channel flow or rectangular channel section. In this rectangle only, you have one more, that is wide rectangular channel sections. Wide rectangular channel section. What happens in this wide rectangular channel section is your width is very greater, means the width of the flow is very greater as compared to the depth of flow. I've tried to make you understand through this diagram. You can see the width of this rectangular channel section is very greater, is much higher as compared to your depth of flow. So this is the width and this is your depth of flow. This you have to keep in mind, because why I am telling this, whenever there are questions regarding the rectangular channel sections, just see whether it is only rectangular channel sections or very wide rectangular channel sections. Fine, just see that first. So here for wide rectangular channel section, width is very greater as compared to your depth of flow. Fine. Now after this rectangle, the second shape is your triangle. Now how can be a triangular channel section? This is something like this. This is triangular channel section. Fine. Similarly, I can draw trapezoidal also. Trapezoidal. This is somewhat like this. Fine. This is your trapezoidal channel section. Now, similarly, you can draw circular also. But yeah, what you have to keep in mind is it should be subjected to what? subjected to free surface. Fine. So here, drawing a circular channel section, somewhat got distorted. Assume it to be circular now. This is your circular channel section. Fine. This is your circular channel sections. Now, could you tell me some other types based on shape? We have studied rectangle, wild rectangular, triangle, trapezoidal, circular. Can I also write parabolic shape? Can I write? Of course, there can be any shape. So, there can be parabolic channel also. Something like this shape. Fine. They can be exponential, also you can say exponential channels. But here this parabolic, what you will see is the expression for this parabolic channel. Let us assume this is the top width. I'll tell you regarding the geometric parameters in the upcoming classes. But here I'm just telling you this is your top width. So for this case, T is equal to C y to the power half if this is your depth of flow. This is the expression which you get for parabolic channel where C is a constant. This is for parabolic, while if it is some sort of exponential channel, or you can say here, this is for exponential. Fine, some other shape. So here you saw this top width. If you are having the confusion, you don't have to worry what is this top width. We will be dealing in the upcoming lectures regarding the geometric parameters. In that, it will be very much clear to you. Fine. So here, first one, I classified all the types of open channel flow based on shape. Now, moving to the second one, that is based on construction. Now come on, this is very much simple. You only tell me, based on construction, how the open channel flow can be classified. So, based on construction. So, based on construction, basically there are two types. First one is your natural and the other one is your artificial. Fine. Now you can define by yourself. Channel sections which exist naturally in nature, that is your natural channel sections, while the channel sections which is being constructed by human beings, by mans, or which are man-made, that are your artificial channel sections. Fine. So I can write it. Channels which exist naturally in nature. Fine. And artificial channels, channels which are artificially constructed, that is man-made, constructed by humans, or you can write that is man-made channels. Fine. Now, if I ask you, what is the example of artificial channels? What is the example of artificial channels? Could you give me any example? Come on, fast. Could you give me any example? Yes. The example for artificial channel is lined canals. What is this lined canals basically? I'll tell you. What happens is, if you are providing any particular shape of open channel flow, let us suppose here I'll take a rectangle channel section. And what you are doing is, in this boundary you are providing lining. Now you will ask, lining of what, ma'am? Lining of, be it concrete lining, maybe of any brick lining. You're providing any lining. Let us suppose concrete lining you're providing it. So that, the reason for providing lining, so that no seepage occurs. So this lined canals or sewer canals, fine. These are the examples of your artificial canals, fine, or you can say man-made canals or channel sections. While all the channel sections which normally exist naturally in nature, they are the example of natural channels. So we have dealt with the second part also. The third part of the types of open channel flow is based on cross section and slope. Now, come on. You have heard the name of this, just tell me first, prismatic channels and non-prismatic channels. Have you heard? If you haven't heard, no problem, but I'm just asking, have you heard the name of this prismatic channels and non-prismatic channels? Now, what is happening is, if, first I'll deal with prismatic channel. If your cross-sectional shape, size and bottom slope, what I told, cross-sectional shape, size and bottom slope are constant, then you can say the channel is prismatic. And if any one out of the three is not constant, it is varying with respect to the distance, with respect to the time, then it is the case of non-prismatic channel. Fine. So I can write, if cross-sectional shape, size and bottom slope, or you can say bed slope, are constant, then it is termed as prismatic channels, else non-prismatic channel. Fine. Now, it's not possible for me to draw the 3D diagram in 2D, this 2D board, but still, I'll just to make you understand, I'll try. Suppose this is a cross-sectional area A1. Let me draw. So some sort of cross-sectional area A2. And if I'll extend it further, just let us suppose this is some sort of your A3. You have a certain slope here, let S be bottom slope, or you can say S0 also. Fine, you are seeing this. Now what happens is, in this channel section, if I say A1, just first let us suppose till here, okay? So this one, A1 is not equal to A2. If it happens, then it will be the case of non-prismatic channel sections. I'm not interested where SB1 or SB2 is equal or not. If any of the parameters, if they vary, then it will be the case of non-prismatic channel section. So this is non-prismatic. While what happens is, if in this figure, if I say A1, although it is not appearing that all these three areas are equal, but if I say that, let us suppose A1 is equal to A2 is equal to A3 and the bed slope is equal, then this will be the case of your prismatic channel. Fine, you're getting it. If all the cross-sectional shape, size and bed slope are equal, then it is your prismatic channel. And if any one of all these three varies, then it will be the case of your non-prismatic channel sections. Non-prismatic channel sections, if you are asking me the example, so all the natural channels which exist, which are there naturally, they are the examples of your non-prismatic channel sections. Well, if you are asking prismatic channel sections, so they are basically constructed by humans, by all the dimensioning, proper alignment, proper layout of the structure. Fine. So here we have dealt with the three part. Now we will be moving to the last one, that is based on boundary characteristic. So now, in this based on boundary characteristics, you will be differentiating with respect to two different terms. So, let me write based on boundary characteristic. Fine. On the basis of this, it can be in two parts, that is, one is your rigid boundary open channel flow and the other one is your mobile, because if it is rigid, the antonium of it, or you can say the opposite of rigid, is mobile. So, mobile boundary open channel flow. Now, just by looking at the name, could you tell me what is the difference between the rigid boundary open channel flow and mobile boundary open channel flow? Come on, this is very much simple. You can tell me. Now, before going to this part of boundary, just two terms which I want you is, have you heard the term of silting and scouring? Do you know what is this silting and what is this scouring? What happens is, silting, basically you also say deposition. What happens is when the flow occurs and it carries with it a large amount of silt, and when it flows to other places, it deposits the silt. So we say that at this place silting occurs, deposition occurs. So that is your silting. Silting is your deposition. While scouring means erosion. You have heard the term somewhere like scouring bed. Fine. So it is like the erosion of the particles of the soil have occurred. That is your scouring. Fine. So why these terms are important? Because whenever I say silting, you should understand what is the silting. Silting is the deposition. What is scouring? It is the erosion. Fine. So now what happens is, in rigid boundary, rigid means what? If I say that something is very rigid, means it is very firm, it is very stiff. Fine. So that is simple. Here also it is rigid boundary. In rigid boundary, what happens is, the boundaries, because like I told you regarding the trapezoidal channel section, we see this one. If these boundaries, these are very stiff, these are not deformable, because neither silting occurs nor scouring occurs. So because of that, there is no deformation in the boundaries. Then it will be the case of your rigid boundary open channel. So what points I can write is, first one is your boundaries are not deformable. Boundaries are not deformable. Silting. In some books you will find, because of silting and scouring doesn't take place, boundaries are not deformable. In other books it is written that although silting and scouring takes place, but the boundaries are not deformable. But generally silting and scouring, we assume it. Actually rigid boundary open channel flow is not that much prevalent and it is not that much you can see in practicality. But for study purposes we are telling it silting and scouring doesn't take place. Fine. Now, what happens is basically when you are dealing with boundary characteristics, there are 4 parameters. That is, I'll tell you, that is your bed slope, depth, width, and layout. Now, what happens is when you are having these 4 parameters and I ask you what are the parameters which vary in rigid boundaries, then what you will tell me? Come on, I have written these 2 statements. With the help of this, could you tell me that out of these 4 parameters, how many parameters will vary and what are the parameters which will be constant? Come on, just think once. You can say, ma'am, you have written boundaries are not deformable. That means the bed slope, the width and the layout, the geometry will remain constant. What will vary is the depth of flow. So I can say that when rigid boundary open channel flow is considered, it has only 1 degree of freedom, that is the depth of flow. So I can write this in it possesses one degree of freedom that is the depth of flow. Fine. Now all the things which are there in rigid boundary open channel flow, just opposite of that will be in the case of mobile boundary open channel flow. What? Here boundaries are not deformable. You can write it here. Boundaries are deformable. Second one, here it is written, silting and scouring doesn't take place. We will write it here, silting and scouring, that is deposition and erosion takes place. Silting and scouring takes place. Third one is here it is told that it possesses 1 degree of freedom, that is the depth of flow. While in the case of mobile boundary channel, as it has already been written that boundaries are deformable. So the bed slope will vary, the depth will vary, the width will vary and the geometry will also vary. So I can write it here, it possesses 4 degree of freedom. Fine. So these are the differences between your rigid boundary open channel flow and these are the differences of your mobile boundary open channel flow. Now, although we have classified regarding the types of open channel flow, but while we'll be solving numerical part, we'll be dealing only with rigid boundary and prismatic channel sections as far as your numerical point is concerned. So I'll write a note here. Let me erase it. I'll write a note. In open channel flow, prismatic and rigid boundary open channel flow, or we can say, right, in open channel flow, we will be dealing with prismatic and rigid boundary open channel flow. Fine. So as I told you, prismatic, the cross-sectional shape, size and bed slope will remain constant, while if I am telling rigid boundary, it will have only 1 degree of freedom, that is your depth of flow. So you have seen here, we have dealt with all the permutation and combinations of the types of open channel flow. We will be dealing with prismatic and rigid boundary open channel flow, or we will be focusing. Fine, both are right. So I hope this is very much clear to you. What are the types of open channel flow? In the next lecture, we'll be dealing with the geometric parameters. What are the geometric parameters of the open channel flow? And like we'll be dealing with some denotions, and this whole open channel flow, when I'll be dealing, we'll be using that denotions only. Fine. So just write all these, or if you have understood, that is well and good. This was just an introduction, because whenever you encountered the word prismatic or you encountered the word of rigid boundary, you should be able to identify what does it signifies. Fine. So I hope you enjoyed this lecture. We'll be moving to the next one. Thank you.